How can we model infection dynamics within the respiratory tract? How are models for viral mutation applicable to H5N1 influenza? And what is it like working collaboratively on a short 3-month project? We explore these questions and more in this episode of SBIDER Presents.
This is SBIDER Presents, a series produced by the SBIDER Podcast Hub. My name is Laura Guzman.
And mine is Ed Hill. In this episode, we're joined by Daniel Higgins, Josh Looker and Robert Sunnucks. All three are MSc students from the Mathematics Real-World Systems Centre for Doctoral Training, which has an acronym MathSys, based at the University of Warwick. We'll be discussing work done recently, initially as a 3-month research study group project, forming part of their MSc programme. At the time of the recording, their study, introducing a framework for intra-host dynamics and mutations modelling of H5N1 influenza infection in humans, is being written into a research article. Join us to hear from the group both the research progress that was made and their experiences as they reflect on the time working on the project together. Hi everyone, welcome to SBIDER Presents and thank you for joining us today.
Hi, I'm Daniel.
I'm Josh.
I'm Rob.
So before getting into what our research project was about, it's probably important that we give you a bit of background as to what all of our research histories are and whether we've had any previous knowledge of epidemics modelling, for example. Myself, I went to university undergrad in New Zealand, and as part of that, I ended up joining the COVID modelling team as a inter-host modeller, so specifically conducting research work around a network model of the New Zealand population. So I had a bit of a background working in a research group previously, but none of it was any sort of in-host modelling. It was all modelling the spread between humans.
I have a background in terms of research somewhat, in that I did a master's here at Warwick. However, that was not in epidemiology, so this is my first time doing a research project in epidemiology.
And I don't have any academic research background in epidemiology or otherwise. So this was my first project in academic research.
That's brilliant. Thank you for your introductions. And that really shows varied experiences up to this point and at the kind of entry points of doing this research projects, how you all had different skill sets essentially that you could all bring into this. And so for this particular project, what was it that you found perhaps most interesting? Because perhaps there was a selection of projects which you could have taken on for this, but was there anything particular about this project that you found most appealing? And for a group project, was there anything you were sort of apprehensive about or didn't know what to expect?
Yeah, so I think it's fair to say that when I heard that we had to do a group project, I was a bit apprehensive. You hear kind of horror stories, I suppose, all the time about individuals not doing anything in their research projects together. As it turned out, it was a really good experience, so those fears were unfounded. For me, in terms of what the appeals of this project were in comparison to the other projects we were pitched, I definitely felt that this had more of a real-world application, more of a really ready real-world application. Even when we were pitched it, I think bird flu was something that was being talked about in epidemiological circles. And now, as it's turned out a few months later, this is now not just something that epidemiologists are concerned about, but, you see reading on the news almost every day about new cases, whether it be in cattle or I think even recently in humans.
Yeah, just jumping off the back of that, for me, the applicability of our research to the ongoing zoonotic spread of H5N1 was a big draw card for me. Secondly, having done modelling work before, I knew that I would enjoy doing some sort of mathematical modelling of a compartment model or so on and so forth. But having never done in-host modelling before, I saw that personally as an interesting and appealing new project to sink my teeth into. In terms of any sort of apprehensions I had going onto the project, I did know that my group members hadn't really worked in research before, and so I wasn't sure whether we would necessarily gel as a group or whether we would have, due to our different backgrounds, different ideas of how to get stuff done and share the workload and stuff like that. But none of those ended up being founded in reality, so that was nice, I guess.
Yeah, I'd have to agree with the others in the most part. Obviously the apprehensions of working with others who we're not entirely sure how we'll collaborate, but again, those fears were put to bed pretty early on in the research project. I think seeing a different sort of modelling that I was used to seeing in epidemiological research, within host modelling, was of particular interest. So as soon as I saw that, I was really, really keen for this project.
And then from my own perspective, I was coming from the more supervisory side, so I had involvement in this project as an academic supervisor, but there was also external partners from UK HSA, so the UK Health Security Agency, involved. And so I think always with a project like this, so you bring together people from the research students, the academic supervisors, the external partner. It's like, how will this all work together as a cohesive unit? But I'd say as over the course of the project, I'd say this has been a very strong example of like all three components being brought together and working in synergy quite nicely. So that's been kind of very nice to see. And I myself don't know much about within host modelling, so it's been quite a lot of learning experience for me on that research side as well, which has been great. Delving into some of the specifics of the work that you've done, what were perhaps at the outset the initial aims of the project, and then did anything change over the course of the 3 months while you were carrying out the work?
Yeah, I think from what I remember at the start of the project, it was a fairly broad kind of set of objectives. Like the main one was, the main two were, can we develop an in-host model for H5N1, and can we develop some sort of mutation model to in some way quantify the chances, the probability of human-to-human transmissibility evolving from the current H5N1 strains which are present in the avian population. I think these definitely did change. That, like I say, at the start of the project they were pretty broad, so there was an understanding that this was a fairly limited time project, and both the external partners and the supervisors and ourselves, we really didn't know how long anything would take. We didn't know how far down the road we could get. And so some of the things that we set out to do from the start and even halfway through the project, the paths diverged from what we expected. But I think broadly, those two key objectives of the within host model and the mutation model, we carried that out, and I think we carried it out really well.
In particular, I think something that we were trying to do at the very beginning was to throw almost every single biological process that exists within the human respiratory tract and immune system at our data set. That turned out to be quite infeasible just by the lack of data associated with this project. And we found that we could get very good model fits using a much simpler model to our benefit. Something that we thought would be useful in terms of the mutations modelling that we didn't end up getting to was for COVID, for example, it was found that immunocompromised people were associated with longer terms of infection, and this led to, for example, in Africa, variants of concern arising through mutation. For our project, it was less clear how would that actually arise in terms of how we would model it, and so that was something that was left, although we had an idea of what we could do, it was left uncompleted at the end of the project.
Yeah, I would have to agree with the two of them as well about these. Those were the main goals. There was a sort of tertiary goal we kind of had in mind of being able to have some sort of, or better quantify some sort of trade-off between the severity of this disease versus the infectivity of it, especially considering if there were a possible human-to-human mutation. However, we quickly realized that this would not be feasible with the modeling that we could do due to the lack of understanding of this mutation and the fact that this is primarily not at least at the moment, a mathematical question, but one for virologists to study.
Reflecting back on some of the kind of earlier remarks that Daniel raised, that's being very broad, the broad aims initially, and actually in terms of the design of these projects is thinking about what could be achievable in the space of 3 months, also what could be interesting for a group to tackle, and again with that initial phase of not necessarily knowing how will the group work together, how will the external partner, the academic partners, etc., all come together to work cohesively. So perhaps by design things are left quite broad, because then also from your side it gives the opportunity for you to then focus in on, we're very interested in this aspect, so let's go further down that path. always within this situation, it's a balance between very prescribed tasks, which we think could be achievable in a time-constrained window, in this case 3 months, while also allowing for this is an opportunity for you to experience research, giving you the flexibility to go down the route which you find most interesting. What were perhaps the main types of methods or like kind of main types of models which were made use of to now try to inform these aims?
So the first model we attempted to use was a 2-patch within-host infection model. The idea here, again, to try and understand how the infection would develop within a human host. As such, we decided to split the respiratory tracts into an upper and lower compartment because of the different properties of the upper and lower. And then within these compartments, we had cells which could get infected and produce viruses, as well as a sort of free pool of virions that could move between compartments through various fluid mechanical forces. Now, that was our main model for the within host. Again, these different compartments and the different properties actually became very useful in sort of understanding how the disease spread within the human host due to these different properties, again, such as the lower respiratory tract primarily pushing virions upwards more than it pulled down from the upper, and also the greater immune response in the lower. That led us to just totally remove the immune response in the upper dynamics.
And then from that, we were able to, and the data that we had available for H5N1 infections, we were able to do some parameter inference, which I'm sure Josh can talk a bit more about. And from these parameters which we inferred, we then built an adaptation of a branching process model from the literature, which looked at mutations in viruses. And the big difference between the mutation model which we came up with and that, those which have been proposed in the past, was that we wanted to capture the changes in the total, the viral population within the host. In the past, these hadn't really been studied. It was kind of assumed that you have some sort of constant viral load. And while that makes your mathematics and the calculations very, very simple, this really neglects a big part of what it means to be infected. So we were able to adapt those models to account for the changes in the amount of viruses you have within your body. And so while the branching process model and the ODE in-host models were not necessarily combined into one, it was more like the in-host model informed the parameters which we used for the mutation model. And the mutation model is really where the key discussion points came from.
I guess just quickly to talk about that framework, as Dan said, that's the main takeaway, I guess the main novelty of combining the two models. So as he suggested, we formed what's called a parameter inference, which is just like a selection of values for the spreading rate, the production rate of free virions, and other associated model parameters that give what we would consider a good fit to the data. And then from that, you can run your model for infection within a host across the set of parameters that we think give a good fit. From that, as Dan said, we can come up with some sort of incidence of new virions per day. And that was the main time-dependent parameter that we used to feed into the branching process model that has not been explored under that modeling framework beforehand.
Thank you for the comprehensive overview, and I think that shows just the breadth of different modeling approaches that were used, and also then, given the range of aims, how then working collectively, then able to kind of compartmentalize certain tasks, but then bring it all back together to then use these different modeling techniques in combination to then help address the research questions. It shows kind of the how powerful it can be to working in collaborative ways and using multiple techniques. So from these multiple pieces of modeling analyses, from each of you, is there a particular result that you would like the listeners to take away?
So I think the kind of big question was, how likely is it that, if you were just infected by an avian, your H5N1 strain could mutate to be human-to-human transmissible? And the big answer is, we don't think it's particularly likely. We don't see that this pathway of going from an avian to a human to another human is much of a concern, and we believe that probably other pathways, for example, from avian to another mammal, for example, with the so-called Mu flu that we've seen in America, for example, could be a much more likely pathway for this disease to become human-to-human transmissible.
As I mentioned previously, one of the novel results that I guess came out of this project was the development of a framework for combining different models together, specifically to do with infection and mutation. And I think it's important that we highlight that although we applied this to H5N1, it can also be applied to pretty much any other disease within a human or other species that we know we can model and host infection with that has a similar mutation model as well. Specifically in this case, respiratory viruses. And you can, again, work out a sort of probability that you reach the required number of mutations for a viral outcome of your choice.
Yeah, I would have to agree, those were the two main outcomes, but I think it's also important to highlight that, we had very little data to work with here. And despite that, we were able to come up with some pretty good results. Obviously, more data would be great, as we could then reduce the uncertainty we have. However, with applying to this, especially with applying this to other possible diseases, H5N1 has very, very small data set available to us, and if we can use it for H5N1, there's no reason we couldn't then apply this to other diseases.
Spoken by a true mathematical modeler, it's like always need more data, or the data we have is like there's always some aspects like can this be improved, etc. From those three responses, I think that really shows how, in terms of implications of this, there's perhaps direct implication to thinking back to the question about possibility of like a human-to-human transmissible strain for H5N1 influenza, but then also the fact you are adding to the kind of toolkits for modelers and how this can be generalized to other pathogens. It could be like a really, really helpful addition and can perhaps open the door to data sets that already exist for other pathogens, but perhaps might not have been analysed in this way, for such analyses to be carried out. So you've already indicated some of perhaps the main outcomes, implications, and also some of the limitations from the study. Are there any others that you would like to highlight?
I don't have anything additional really that I want to highlight. I think I will just echo Rob's point about data. I know that kind of in all aspects of epidemiology, data is a bit of a joke because we always want more, but really for H5N1 it was such a limited sample size, so few degrees of freedom to work from, and I'm really proud of the work that we managed to do despite that. But and obviously coming up with a framework means that as and when more data becomes available, it'll be easy to, extend the results that we have for that new data. And so I suppose this is more of a bit of a plea to if anyone's listening who is involved in this sort of thing, that we really do need data to get concrete answers. And while as I say we're very pleased with what we've done, more data can definitely not hurt.
Whilst I guess I don't want to echo the same sentiment over and over again, I think it is important to note that for our dataset in particular, it was linked to H5N1 infection, for hospitalized cases in Vietnam, and this isn't necessarily representative of the average H5N1 infection that might arise from avians in the current zoonotic outbreaks. For example, I think I was reading the other day that within the dairy workers that were infected in the US, they ended up with some infections in their eyes as opposed to in their respiratory tract primarily, which obviously we did not model. So I guess it's less of a plea, but more of like a interesting thing to note that maybe other models could be used once the data, again, becomes available to consider these other types of ways that H5N1 could infect someone. And it's not necessarily a limitation, but just scope for future work, I guess.
Yeah, I mean, I won't repeat the same points for the umpteenth time in a row, but generally, our main implications were, this framework, this chance of mutation spreading to other humans, and obviously the data point.
I believe what this really strongly shows is how, with certain approaches, methodologies, you can only get so far. Bringing in expertise, different disciplines, etc., is crucial for us to make collective progress towards answering problems like this. So, say, without having kind of the clinical side, the medical perspective, without having the relevant data collection, without then having kind of the quantitative or modelling type approaches. All of these can contribute an element to helping progress the knowledge base around this, and then bringing it all together collectively. I think it's like the sum of the parts is more than like each piece individually. So then hopefully through this project, it's giving that exposure as well to working with real world data, and there's a discussion to it to then basically help progress is what could help improve both future data collection, what will be most useful, and what could be improvements in the modelling side that will make use of the data that is currently available and could be collected in the future. Thank you for overviewing the study and the main results. So now at this current stage, are there any now kind of perhaps new questions that have arisen, or anything which is kind of unanswered, which you're would be kind of very keen to explore in the future?
Yeah, as mentioned earlier, we don't really know much about how immunocompromised people might sort of deal with this disease. In the past, similar diseases such as the Spanish flu, you didn't actually see immunocompromised people being worse off. In fact, they were actually more likely to survive. So being able to some way model these immunocompromised people, obviously data will be an issue here, but if that were possible, that could provide real insight into if that is a highly probable route of human-to-human transmission or not.
I think for me, personally, now that there's more cases, for example, in cows, but also in mice, who we know have more of a similar respiratory system to humans. I mean, in terms of the study, we also modelled some of our lower immune system response, the lower respiratory tract response, after studies that were done in mice as a result of H5N1 infection. If we can get mutation data from them about the number of mutations that occur in the host, I think there's in mice, I think there's a broad scope for extending our framework with this new information, specifically because if you start, as we have highlighted, we think it's unlikely to get human-to-human transmission just from avians, but because there's now the open question of what happens if it goes through a cow to a human, or now through mice to human. If more information about those mutations come around, then we can chuck our maths brains back at it and see what this has in terms of differences in the modelling results.
Great, thank you. And so to conclude our discussion, so we've already remarked upon how perhaps within research things can be very collaborative, and teamwork is such a crucial aspect. From your experiences from this 3-month project, what are the experiences which you would take forward into future work and apply? And is there anything that you would plan to do differently?
Yeah, I think the big thing that really struck me was the days where we made the most progress. We came into the office and just chatted about, where we thought the project could go. And even if we didn't make any sort of concrete sort of steps forward, it really gave us a clear sort of pathway of the direction that we wanted the project to go. And it didn't really occur to me that those really super collaborative days, and sort of in between, we'd maybe come in once a week or even twice a week and work on stuff together in front of the blackboard. And that was so useful. And it really hadn't occurred to me before that I kind of had this idea that we would be doing individual work and then combining it together, and we wouldn't be working on it truly as a group. And so that really surprised me, pleasantly surprised me. And it's something that I think, I'll make sure that even when I'm doing my own individual research, that if I have things where there's some overlap with my colleagues, I know, for example, that me and Josh are doing something similar going forward, that we'll make sure to bounce ideas off each other and bring new perspectives to things. And I think that's pretty invaluable.
Yeah, I think what was also quite useful is, obviously, if you work by yourself, you are primarily the only person who is going to be checking your work until you then compile it all together and present it nicely. When you work on it with someone else, if you make an error which you don't see immediately, it's quite likely they're going to pick it up. I speak from experience in that I had a very small error in my code, which didn't cause any immediate issues and wasn't immediately noticeable, but was gladly picked up on by my colleagues. So yeah, that was very useful. And going forward, again, that using other people just to have sort of sanity checks sometimes can be very, very useful.
I guess my personal experiences kind of summarize my colleagues' thoughts that they've both put together, in that my previous research group experience was, well, being a COVID modeler during COVID. So most of the work that I did that was research work was kind of siloed at home, where I just saw my colleagues on a laptop screen, and I didn't have a blackboard to write down nice maths with. So it's been a very welcome change to, as Dan said, just stand in front of a blackboard with other people to check my maths and check their maths and even just discuss ideas. In terms of Rob's point about coding errors, I didn't get to do any sort of like peer coding whilst I was code modeling online, but just sitting down or even discussing what your code does in front of other people, similar to like how you would explain your maths equation logic, I feel like is a really good method that I'm going to take away to pick up any errors both that you made or maybe your friend made, that sort of thing. So yeah, it's been a much welcome change to do research work in person.
That process of explaining the thought process, or like just going line by line, what is this code doing, it's remarkable then how quickly that can suddenly reveal. It's like, oh wait, are we assuming something here? Do we mean to make such an assumption? Is this line, I know what I meant it should be doing, or I know what I intended it to do, but is it actually doing what it should be doing? Yeah, so having, as I say, that kind of sanity check kind of process is super, super valuable. Thank you to Daniel, Josh and Rob for joining me today. It's been this project overall has been very exciting. It's been really cool to see the direction it's taken. I'm excited to see basically how it continues from this point.
Thank you for the opportunity. It's been nice sharing the results of our research, and yeah, I look forward to seeing what comes out of the end of this project.
Yeah, thank you very much. Yeah, it's been a great experience, and I'm very much looking forward to getting this all written up in a nice report.
Cheers.
And thank you to everyone for listening, and we hope you will join us again for our next episode of SBIDER Presents.